Daniel Waddell is a senior principal cloud engineer at MetLife. Daniel's roots are grounded in architecting highly available applications and operationalizing cloud infrastructure at enterprise scale. In this conversation, we discuss the enterprise adoption culture, challenges, and strategy of Kubernetes. Daniel Waddell, how's it going, sir?
It's going well, Mr. Collins. It's been a while since I've seen your lovely face. It's good seeing you again.
I know we live so far away that it just wouldn't make sense to meet up in person now, would it?
Yeah, right. It's funny. For the longest time, I didn't know we lived close. It was not in my brain. I don't know why, but I had a perception that you lived in a different state.
Yeah, are you actually on the southern Indiana side or the Kentucky side?
No, I'm in on the east side of Louisville, pretty close to Oldham County, but still within Jefferson.
Right on. So I'm technically an Indiana resident. I'll just leave that where it is.
Yeah, yeah.
Um,
So you do live in another state. I wasn't wrong.
I do. Yeah, you're absolutely right. You've got a lot of data to back that decision now, or that statement. So
Yeah.
yeah. So what I wanted to talk to you about, in an area that you were, what do they say, like 10,000 hours makes you like an expert at something. I bet you probably have about 10,000 hours in Kubernetes at this point. A lot of time. So
yeah, that's a good guess. Probably hitting those numbers pretty solidly now. More on the infrastructure side, though, instead of the app dev side. I have an app dev background. That's what I started my career as. 20 years in application development, and then, but during that application development, I had my hand into Kubernetes just as hosting workloads. Mostly somebody else managed the Kubernetes, but then I pivoted into infrastructure. Yep.
Yeah. Why don't let's start with your background. Where did you, so before, for the audience out there, Daniel and I had the great opportunity to work together on a lot of challenging problems for a big organization. But what did you do before that? Tell us a little about your app dev experience.
Yeah, so I've bounced between industries, mostly doing .NET development, with a myriad of different front-end technologies like Angular and React and Vue.js and a number of other defunct JavaScript libraries, but mainly back-end development, full stack, with .NET, SQL Server, mostly Microsoft-based products. As you know, I'm from Louisville, Kentucky, and we're a very heavy Microsoft city. So if you want to get good jobs here, at least historically, it was .NET. So the Microsoft stack. Then let's see. I did some work for the public sector, for the financial sector. Didn't really get into big corporate organizations until you and I worked together, which is where the running Kubernetes at scale conversation started, which are, I think, going to be the topic of our conversation here today.
So yeah, Kubernetes at scale. Like, first off, Kubernetes. Why would, what makes Kubernetes a game changer, I guess, in the cloud native world? Or is it just overhyped, somewhere between sunshine and rainbows? What do you think?
So containers are the game changer. And Kubernetes is a technology that makes containers accessible for infrastructure groups to use. The evolution of Kubernetes, however, is interesting because it was designed for infrastructure people to allow tenants to onboard. Like, it was really supposed to be a consumer agnostic technology where you didn't know it was really running on Kubernetes. You were creating a workload, defining it, and Kubernetes was operating it. But then the concept of shift left came, which infrastructure has always been a bottleneck and will continue being a bottleneck until it can fully be automated. And part of that paradigm shift to let developers work faster is just give them the technology. And so what happened is they took this really back-end heavy technology and said, here, just manage it yourself. And so while containers are major paradigm shift that brings a lot of values to business, and Kubernetes makes containers easy, it really isn't easy for our developers who now have to manage CI/CD pipelines and Kubernetes clusters and honestly just make mistakes when they're operating them, because nobody can be an expert in all technologies. You really typically pick one and you focus heavily on it, and then you make mistakes in the other if you're really asked to do it well.
Right. Yeah, that makes a lot of sense. Yeah, I remember the beginnings, the humble beginnings of, hey, it's out of sight, out of mind. That's the intention. And I think that's the ultimate goal. Like I heard Kelsey Hightower talking about this the other day about like where he believes Kubernetes is going to be. It was on a podcast with the financial czar, Corey Quinn from the Duckbill Group. I'll put the link in the show notes, but it was interesting. He talks about what his vision of what Kubernetes could become is. It was rather interesting. But yeah, now it's again, you can't take your Ferrari down the highway unless there's a highway to drive it down, or else you're going to be in trouble. So yeah.
Yeah, a lot of the groups behind Kubernetes, though, they're working toward the problem that has arisen, which is shifting left, is giving the developers control of the clusters. There are a lot of technologies coming down the pipe that are promising, like virtual clusters, where you can really take your operational heavy items, shift it to the right. I guess give it back to infrastructure people who have specialized in it, but then give your developers the feeling as if they're administrators on their own cluster, and they can operate those pieces that they really do. They really need to operate scale. They really do need to operate resource utilization and quotas and things like that. So it's a nice compromise, and the cloud native cloud foundation organization that really sets a lot of the standards around Kubernetes is really pushing hard on those technologies over the last few years, and I'm excited to see where they land.
Yeah, so you're basically saying like, okay, kubectl is an admin function. There's very few admins. When it comes down to the developer, they're going to be interacting through like pipelines specifically, and only able to do what they're need to do to like scale what they need to scale.
Yeah, but they can still log in and run commands. I mean, that's really what your developers don't want to manage the cluster, but they want to load a command prompt and execute commands, because if you're on a SEV incident and you need to gather information, you don't want to wait for other people to get online to get you the information you need. You want to execute it. And then if you're in a dev environment, you forgot to set up some kind of logging, or some kind of logging's not working, so you can't see it. You need to log in and you need to execute commands and see what's happening. And that's one of those things that sets off security radars, and you get incidents that have to be triaged and looked into because somebody wanted to get their logs, or maybe you're so Loctite that they can't execute anything, and then your developers are twiddling their thumbs for hours waiting for somebody to come in and operationally give them what they need. So the virtual cluster kind of can solve some of those problems, and I'm excited to see where they land.
For sure. I was just thinking just now, like several years back, we had another kid, and my wife comes up to me and says, "Hey, we've got to get a bigger car. We can't fit in our current car. Henry can't bend his legs. It's awful. And I'm like, why do we need a bigger car? Why? Explain it to me. Of course, because I'm, trying to be data driven in my personal life, of course. But if you think about like Kubernetes, um, you know, running for the hyperscalers, like you think Google, of course, like they are running things at scale globally, extremely distributed, workloads. But what about enterprise? Do enterprises really need uh, something like Kubernetes to solve problems at the type of scale that like Google or ChatGPT solves problems at scale with?
So enterprise and really struggles with, well, non-tech heavy enterprise struggle with high SLAs, like just being able to deliver a product with a known uptime, with a known risk assessment, and Kubernetes can really bridge that as long as you're not saying, here, developers, you manage these Kubernetes clusters. Because then it becomes unpredictable again. You're yes, from an infrastructure standpoint, you've created a Kubernetes cluster that has a 99.5% uptime. And maybe you've created two and you've load balanced the two for applications. But if the load balancer is not set up correctly, if a developer makes a mistake on the workload and it brings it down, then you're not delivering on that SLA. But the shift left mentality has been able to say, well, the infrastructure people will say, well, I delivered on my SLA, and it was after the fact that this broke. So if you can create a managed Kubernetes offering, which is what Kubernetes was intended to be, so you have an elite force of Kubernetes engineers who are taking the SLA from the infrastructure delivery side and bridging the gap to the workload. That's where enterprise can really see benefits from Kubernetes. But like saying, hey, here's a Kubernetes cluster for one workload, you're not really going to gain much from that. You might as well use a PaaS offering or a SaaS offering that takes a container definition and runs it exactly how your Kubernetes cluster would, but removes all the complexity of managing to make sure that workload stays online. All the cloud providers offer them, either AKS, EKS, or GKE. Like they're available, and they all run containers, and they kind of take that management away. Now, I know you probably have some security professionals who listen to this show. That, of course, raises some red flags in the security department. So, you, if you want to go Kubernetes, you really need to invest in those cluster engineers, the Kubernetes engineers who are going to manage the workloads for you. They're going to allow things like fail over to another Kubernetes cluster, migrate a workload to a brand new cluster that you just stood up. The things that the big cloud, the CSPs provide for you. Like, you don't have to worry about it because it just happens. Well, enterprises can provide that with the right engineering.
But no matter, so what do you think about this? Like, no matter the right level of engineering, like maybe you skilled up, you hired some new folks that have built out practice around Kubernetes to put apps on, and they're not greenfield. You're trying to move some old, 10-tier crazy, nobody knows what's happening with it application to some microservice. You're really back in refactor land, right?
Well, let me see if I understand your question there. So, inside of an enterprise, you can have a development team that is very good at Kubernetes, or maybe they internally have their own Kubernetes engineers that handle workload management for them. And in that case, you can be successful. But I would not call that an enterprise scale deployment of Kubernetes, it's almost like having a startup within an organization, because startups are the perfect example of where Kubernetes can go right and then become an enterprise at scale. Because, of course, if you hire everybody who's a Kubernetes engineer as well as a developer, and then everybody skills up because they're using it day in, day out, and of course, startups typically operate with a little less compliance than your enterprises have to operate under. So they learn their lessons, and then they're capable of bridging into a enterprise scale Kubernetes development. But I haven't seen an instance where it's easy to go from non-containers to containers and then it just operate at scale.
Yeah, so likewise.
Yeah, I mean it really
it's
takes
a tough thing.
takes reskilling a large number of people, and then you have to create your practices around Kubernetes. Now, that's to say that I've definitely seen successes on the micro scale, the individual workloads. You're like, this workload, we're putting it in Kubernetes, and you can do that one at a time, right? You can say, I have a workload, we re-architect, we re-engineer, we move. We re-architect, we re-engineer, and move, and almost do like a factory pattern. That can be successful, but you're not going to operate at the speed and with agility that most enterprises want to operate at. And that's why they shift left. They're just like, give it to the development teams, let them manage their own clusters.
Yeah, I mean, moving. So yeah, I would say even doing the most basic of like lift and shift exercises has been equally challenging for some enterprises to do. Even, it's just different. Cloud is different, and a lot of the frameworks and the foundations and the scaffoldings that need to exist in the cloud usually don't exist at the beginning. You're figuring it out as you go along, and then you have all these things where you're like, oh, I could have done this differently. Oh, they just released a new product that allows me to really simplify this, but you're already like on this like path that's really, really hard to deviate from sometimes. Speaking of parts of the organization that don't like to deviate or compromise, security, especially the higher you get up the stack, can become pretty complicated because in some ways you're, subject to all the prior layers of infrastructure in the stack sometimes. Do you have any challenges that stick out in your mind with, adopting Kubernetes and, bringing in security teams, upskilling in security? Like, is security slow to sort of adopt, going with a containerized pattern and securing it?
Well, containerized pattern, I say yes, but Kubernetes, I would say no. I think a lot of the security engineers and the security architects, they like Kubernetes because it gives them the ability to inject workloads. Like they can have, let's take some CSP provided Kubernetes like AKS. You can't really run containers specifically meant for security like alongside all the workloads to do your monitoring. Now you can get observability data and you can maybe mine that on the back end and you can get some insights, but actually active security is hard in those managed offerings. But there are plenty of vendors that will sell you a product to run on your own Kubernetes clusters that will operate. And that's where the problem comes in. There are so many products that solve niche problems or maybe even big problems that you end up with Kubernetes clusters with too many workloads running on them that are not providing value back to the business. So you have one little, let's take the example of one app per cluster. If you have one application, let's say it's a small, I know you like you used to like the product Hugo for documentation. You have a documentation site running on an entire Kubernetes cluster by itself, and then you have security stack running beside it. Like, what value does the business gain from that being on Kubernetes? And then the answer is none. And that's why you need to tailor your solutions Of course, everything's a trade-off between privacy and security and compliance, and you just have to weigh those. And that's where enterprise scale Kubernetes comes in value. If you have a shared Kubernetes cluster, you can have 1,000 Hugo applications running different sites, and you can have API backends, and they're all running on the same uh, cluster hardware. So you get really high node density of pods. So the execution is hitting 80% utilization, so you never have to worry about wasted money or wasted resources.
Yeah, those are some good points. And like, just kind of thinking about that, like large enterprises, I don't know of any conversation I've probably ever had with a cloud practitioner that worked for an enterprise that didn't have technical debt. Like, you build things over time, and those things evolve, technology changes, you adopt new technologies, and you don't go back and pull every single thing you've ever done into the new pattern that you're bringing in or adopting. So quite a bit of technical debt. And lots of brownfield environment just running amok everywhere. So just thinking in the context of like, these big organizations have a lot of folks that run the data center. They have a lot of folks that run security. Thinking about that org chart, do you hire, like, how do you mix the institutional knowledge with like new knowledge coming in? Like, is it like a 50-50 split? Like, do you probably want to mix new faces with, the folks that know where everything's buried in the organization? Or do you start reskilling the folks that are, in a specific department in these roles to work in cloud? Or is it both?
I don't know. I've tried many mixtures of the two when I'm designing my, the cloud modernization journeys. And I think it really has to do with the enterprise you're dealing with. Like, where is everybody with their skill wise for cloud or for Kubernetes or for any of these technologies? Finding the right mix of reskilling, hiring new talent, and creating like these centers of excellence. Like, there's a good balance, but that balance is going to look different depending on the organization you're working in. So I don't think there's a recipe that you can just write down and give that says, "Hey, do this and you're golden."
I agree 100%. Great answer.
Yeah, and it's the same. I know you're very network heavy background. It's the same with network as it is with cloud and as it is with Kubernetes. Yeah.
Yep. So Kubernetes has clusters which have nodes which run pods, and pods have containers. What is the relationship between these components? Like, how do you operationalize them in the context of an enterprise that has like different teams and different applications and just sprawling infrastructure? Or is that something you even think about?
Well, in an ideal world, your infrastructure people, so your Kubernetes engineers, are worried about the nodes. The nodes are really just the bare metal virtual machines that are, or could be not virtual machines. It's the compute that is operating your workloads within Kubernetes. So typically, an app dev team is not going to have to worry about node pools or nodes unless they're doing something crazy like machine learning that requires NVIDIA GPUs or something like that. They're not really worried about tweaking the performance of those nodes. That's really best left to your engineering teams for the infrastructure. Now, on a node exists pods. Now, pods are, you can really think of them as a virtual machine for your application. So it is when you're trying to optimize workloads and you have, say, a virtual machine that's running one component of your product, you don't necessarily want to spin up another virtual machine to run another component of your product. You get better performance if you can operate those within the same space, within the same virtual machine, we'll say. Well, the same is true in Kubernetes. So they defined a middle layer that is called a pod, which is that sort of minimal deployable unit within one virtual infrastructure. But it can run many services inside of it, and those services are really what the containers are defined as. Because you really want your workload containers to not have to worry about the operating system they're executing in. That's a concern of the pod. And you kind of you declare what kind of pod you want to execute, and so and then your services are packaged inside of that pod, and then the cluster takes care of saying, well, what node can I execute this on, and kind of schedules it based on utilization and any other requirements you've defined in your metadata.
Yeah, it's funny. I've fielded like several, lots of questions over the, past few years about Kubernetes and like, hey, explain it to me, but through like the lens of VMware. Like, what is this maps to this? Is it like a one-to-one mapping? I'm like, no, let's just.
we always declare our biases by the way we ask questions or the way we answer them. Yeah.
So you like VMware, do you? Okay. So, as you alluded to earlier, my favorite discipline in the world is networking. Is networking important in Kubernetes at all, or do you just not need to care about it anymore?
It's important for your Kubernetes engineer, the people who define the cluster itself. And then it's also important to your security people who want to lock down workloads. One of the issues that arises with multi-tenant Kubernetes clusters is how do you identify traffic that's from one application versus another application? Because the scheduler takes care of shifting them around on the nodes. So you can't say, hey, well, this is application 1, I'm going to allow this, and this is application 2, I'm not. So you have to bring that into the cluster itself, because that's the thing that knows what each workload is doing. And that's typically defined as policies, whether you're using just Kubernetes network policies or you bring a product like, there's a myriad of like Calico and Istio and just different control mechanisms into the cluster itself. You have to worry about defining those policies. You also have to, well, actually, I almost glossed over the biggest one you have to worry about, which is IPv4 exhaustion, because with Kubernetes, if you're running it at scale, you might need to use a lot of IP addresses. And interestingly, we've seen a shift, at least from the Microsoft side, going in one direction to try to alleviate that problem within the cluster, but then the industry going in another direction. So they really went heavy in what a product called KubeNet, which kind of adds natting into your cluster, which I'm assuming you have your listeners are network savvy, but if you're not, that's just network address translation. So a single IP address can service many, or even a pool of IP addresses can service many virtual machines or pods or containers, however we want to define that on the back end. Well, they went heavy in bringing that NAT solution into the cluster itself, but the industry's really headed more towards CNI, which takes that and puts each pod on the network. So you have to have an IP address per pod instead of an IP address per node, and that, of course, can be 10,000 running in a single cluster. And each one of them potentially running a tiny Hugo application, and you need 100 IP addresses for your Hugo because you needed it to scale because of your consumption patterns or something like that. Hugo's a bad example because you really should be using a CDN for that, but you know what I'm saying. Basically, one
Yeah.
IP address per pod versus one IP address per node, and that's a hard problem to solve. That the CSPs at least are working on it. AWS
Yeah.
has a good solution. GCP has a good solution. Hopefully, I'm not making any Microsoft people mad, but they don't have a good solution outside of KubeNet. I do know they're working on it, but nothing available yet.
I'll make sure and send the link to this episode to all my Microsoft folks on LinkedIn.
Yeah, yeah.
So,
No, it's a real problem, and I was all in on KubeNet because I was like, this is an easy solution to this problem. But of course, the
yeah.
community spoke, and
So
everybody
KubeNet's like the built-in out of the box networking that exists with the project, right? And then CNI is more third party, isn't it?
No, they both became baked in. Now there are many flavors of CNI, but all the CSPs bring their own. Now you can layer another, like Calico is a CNI provider for networking, but it also works in KubeNet, so my brain's just hurting thinking about it. But all because the CSPs have to bridge what is Kubernetes with what is a VNet, so they kind of make their own flavor of these products to operate within. So AKS felt very much like KubeNet was native because on Azure it was native. That was the easy option, the easy path.
Yeah, this seems like an interesting problem to solve, and I would, I can imagine that, some of these would run out of IP addresses for some reason. I feel like I have a history of running into a brick wall with that, actually.
Yeah. Well, and like I said, AWS and GCP have solved this on their networking layer. They provide NAT gateways, internal NAT gateways. So that fixes it, but it's just hard right now, at least. Hopefully people are listening to this in a month and maybe it's no longer a problem, but at current it's an issue if you're an Azure engineer.
Remembering this is where I feel like the working in networking and also working around Kubernetes, like I feel like the trying to solve problems in certain ways in Kubernetes has a way of like somehow bringing in like network infrastructure teams, because things happen, like something needs to talk, like something's using, it's using the the CIDR block of like a wireless network in the data center or something else, like there's IP overlap, there's like some weird janky stuff going on, or the same CIDR block is used across like a bunch of different VNets or VPCs. And there's some sort of integration things that have to happen. And, the only solution to that is, of course, like natting and some address translation type activity, like at a lower layer in the network, which is never, I usually take a hard stance. No more NAT, but it happens. Do you think like network teams should be brought in sort of in the beginning to kind of field some of these things with the requirements? Or
I think, yeah, and I think it really is a networking reskill has to happen beforehand, not really just coming in and saying, hey, network person, come and look at this. Because it's a complicated conversation and there are lots of technologies involved and they're different depending on which CSP you're on, and really like overlapping IP space and natting is the only good solution so far to meet all the needs. Of course, the easiest solution is you go true cloud native and you put your Kubernetes cluster in its own a segmented VNet that doesn't touch anything internal. But the reality of hybrid networks within enterprise especially is a reality that you have to solve. Like sometimes people need accesses to databases that aren't in the cloud they're in, or maybe it's on-prem. and they're not publicly available due to compliance. So you have to solve it. And right now, natting is the only way, unless one of your listeners wants to send an article on how I could do that better.
I'll let you know. I just random question just hit me out of nowhere. So like what is your thoughts when I say stateless? Like, shifting stuff from, any state from the app to the data layer. What do you think about that whole paradigm shift?
Well, so that's a software development 101 like requirement. You should, if you're writing a good cloud native application, you should never depend on a hard drive like being attached to you and just saving something on it. But because you want to be able to have a scale set and you want to be able to spin up and tear down things. So you really need to have a centralized store to store all that in. And with container definitions, your ability to store data locally has to be shared across containers. And then, of course, Kubernetes solves this for you. You can do that. You can load storage accounts, and you can operate them within your nodes and share them. But then what happens when you need to migrate to another cluster? What needs to happen when you need to migrate to another region for a disaster recovery failover? You really need to have that storage state separate from your Kubernetes cluster, unless you've engineered a really clever solution. Of course, engineering can solve any problem, but the easy solution is to have it be external through a SaaS or PaaS offering that's not within your Kubernetes cluster. So that way it doesn't matter where your container's running in, it can always access. You can move it from Kubernetes to an app service, and it can still access that state.
Yeah, good answer. So going into the next, so just thinking like, you sort of brought up Istio earlier, so I'll pick on Istio. But when is it time to use a service mesh? And working with Istio in particular, I like the way it sort of normalizes the behavior across these environments like AKS, EKS, et cetera. But sort of is the complexity worth it? Like, is that juice worth the squeeze? I heard upgrades can be really challenging with all them breaking changes.
Yeah.
What do you think?
Istio operates very close to the metal within Kubernetes. So if you're not, if you don't have an engineering team that is very disciplined at upgrades, and you're not following an agile release process, and you're upgrading often, then those two can definitely get out of sync. Now, of course, being so close to the metal, Istio is a very stable product. It's only when you're trying to skip versions of Kubernetes because you're not disciplined. You're like saying, well, we're going to go from, 2.2 to 2.6. Like your Istio is going to have to break unless you do some kind of staggered upgrade. But Istio, while it's one of the best service meshes, simply because of the number of contributors, it is a Swiss Army knife. It's not just a service mesh. So I don't know how I feel about enterprise Istio service mesh, like a global service mesh built around Istio, because this is almost as hard and complex of a problem as Kubernetes itself. Like, how do you set that up correctly? Should you use a SaaS service mesh that's outside of Kubernetes? Of course, that's going to help that upgrade process and things like that. But again, we're just layering on more technologies and layering on more external complexity versus internal complexity.
More layers, more abstraction, which sometimes those abstractions come in pretty handy, especially if you're an enterprise that just doesn't have the talent. Talent's really hard to find these days. Like, I think I was talking to someone the other day about like they've managed to find some really good cloud architects, but they haven't been able to keep those cloud architects. So it's just really hard to retain talent. especially in the current market. So
And
when
that's
you can't retain that talent, you have to, buy versus build, it seems like in certain areas.
yeah, that is why I'm a big advocate for the lowered complexity by having separate components. You don't have to have, like, let's say you have Istio and you have Kubernetes, and then of course your security team says you have to have Twistlock or something like that, like Prisma Cloud, and you have to have maybe you have to have Calico because you're not always dealing with microservices. And so you're just layering on technologies, and then you shift it left, and you're saying, hey, cloud developer, .NET developer here, manage this soup. Where I think it's a lot easier to hire talent if you want to focus, if you want to say, hey, we want to find a someone who's really good with this service mesh technology, like but a product specifically for it, like an Anthos or a Tanzu or what have you for service mesh, and then you say our Kubernetes is going to be really a shared offering within an enterprise, so that we have a team that are Kubernetes engineers. They don't know .NET development. They don't know web development. They might not have deployed a workload pod in years to a Kubernetes cluster, because they're really worried about the metal behind the scenes. So then you can micro focus, and then your .NET developers can be .NET developers, and you can really hyper focus your engineering talent on what they're good at versus giving them a bowl of soup and saying eat it.
Yeah, yeah, those are good points. I remember, I don't know if I think it was Jeff Bezos, or it might have been Elon, one of the big tech empire gods out there. But if they basically said, like, if you're not adding back, like, I think it was like 10% of the stuff that you've deleted, then you're not deleting enough. And to challenge like all the requirements that go into that. I mean, I'm probably quoting that really wrong, but basically like deleting all the aspects of something that you don't need, so much so that you're adding some of those back. And I feel like I don't know if it's just I think there's a stigma around security sometimes where before you can like even get an MVP out, they're trying to think of every possible outcome, every possible scenario, all the different things, and then pile all those things onto a thing before they even like run something. They want to have everything in there from like minute one of a workload running.
Yeah.
And it's just, yeah, I just don't even know how you would work with that these days with all the different stuff, throw in service mesh, throw in, the lower layers of the OSI. Like, yeah, it's just madness.
Yeah, I mean that's why I was talking earlier about all of the security software that ends up on a Kubernetes cluster when you have a managed solution within an enterprise, because it's almost like the floodgates get opened. They're moving from fully managed cloud products like app services or function apps, where their ability to put software is limited. They really have to depend on observability data. And then they're like, oh, we're going to move over here to this product, which I can just keep it. I can keep buying products and I can keep adding them on because I want to solve every single possible permutation of issue on day one. Where Kubernetes within a cloud provider gives you more security out of the box than a lot of products, because it's fully privatized. Like you can say, there's no external access to this product at all, through policies, of course. But that is, standard practice. So really, you should always take a workload approach to Kubernetes. Instead of defining what your cluster looks like based upon ideals and principles, you should say, hey, we have these 5 workloads. Let's figure out a way to get them on and secured. And if they're Hugo applications, maybe Kubernetes isn't the right solution. A reasonable approach. You can't always go all in.
I'm still using Hugo to this day with one of my blogs. I love it. It's the whole thing is CI/CD. It's just so easy.
Yeah, you just
like I
type something and hit enter and check it in and walk away, and it's loaded on your phone.
Amazing. Like I had to create a blog the other day, and it was like Medium, I think, and I about cried. I'm like, how do there's so many things to get this published. I mean, I'm being a baby about it, but like when you come to the point of like it's just push button and it does everything versus like going back to a Medium or a DevTO. Yeah.
But that's where you want to get with an enterprise, right? You want an application team to fill out a form, get funding, or maybe they have funding that they can pull from for R&D. And then they just get a Git repository for their language, .NET. Here's your Git repository. Check your .NET code in here, and boom, it's running on a Kubernetes cluster. Like that type of experience is going to attract the talented developers who are very good at their one technology, or who want to become very good at their one technology, because they can spend 8 hours a day focused on that one technology and not have to involve other people to help them figure out how to get observability data into Splunk or Application Insights or Datadog. They don't need to engage someone to become an expert on a new technology every other day.
Yeah, then you have someone like Daniel Waddell hopping from team to team, helping with thing to thing, across the whole technology stack, getting pulled in every direction. Yeah.
Yeah. But as soon as I can fully build that idea, I will be a happy man. It can just fade away and be like, look, it all just runs.
Yeah.
But hopefully one day I'll achieve that goal. And then
we'll see where your time and technology takes us. Well, I guess we better wrap it up. We're hitting close to an hour. Any last words? Where can people find you? Do you do social media, Danny?
The only social media I really do is LinkedIn. You can look me up on LinkedIn. I do. I'm in the process of resurrecting the Azure meetup group in Louisville. So it died with COVID complications, and I am bringing that back in October. So next month, we meet on the second Thursday, so October 12th. I know that October and November will be hosted in the Humana building downtown Louisville, the one near Waterside, so the clock tower. But you can find me there on the second Thursday of the month at 6 p.m. And
awesome. I'll put that in the notes, and I think I'll attend. I know where that building is. And I've been there before.
This is the topic we're talking about on the 12th, is how to do Kubernetes clusters at scale.
Right on. Sweet. Good deal. So you heard it right here, LinkedIn and Azure Meetup. Yeah, our friend Steve actually does the AWS Meetup, doesn't he?
He does, yeah. And for Anthony Sullivan is assisting with the Azure Meetup, because, of course, in order to be in a Humana building, you have to have an employee for obvious reasons. So we have a nice partnership there, and we'll get that going in October.
Right on.
Yep.
Yeah, I'll definitely attend. Well, yeah, thanks for coming on and talking about this really awesome, sometimes polarizing, but very difficult technology to run and operate at scaling enterprise.
Yeah, send me
appreciate it.
Send me any comments you get, because might have to add them to my talk.